This concept of the motherboard architectures of Core Studio system. In that we see in the processor, we see in the MCH, we see in the ICH, then SIO and the BIOS, and then this is the clock chip which give the different frequencies, the storage RAM, and generate a different frequencies like this. Yeah, different frequencies coming out from clock ICs connected to the 14.3 megahertz crystal, which generate a varieties of frequency which is given to the entire motherboard. So this the architecture was going on in 2010. What is happened is the Intel divide these chips MCH, and this RAM controller section, this side he put it into the CPU, and graphics controller section he put it into the ICH, as well as this clock section also connect into ICH. So there will be 4 chips become 2 chips. There are 4 chips, no? One is the processor, another is the MCH, then ICH, and then clock. So the entire motherboard structure is a change, and all the 4 chips become only 2 chips. That is in this section, and that chip's name a platform controller hub, that is called the PCH, the platform controller hub.
PCH using compulsory CPU have the RAM controller?
Yes, the RAM controller inside the processor, that is DDR3 or DDR3L. DDR4 for after 5th generation.
PCH, they don't have RAM controller.
All PCH, all CPU have a RAM controller. PCH doesn't have the RAM controller. PCH have a different work. Processor is a different work. So this processor directly connected to the RAM. He access directly to the RAM. That is a DDR3 or DDR3L. And a CPU have another port that is called a PCI Express. If motherboards they require a graphic chips, then you can connect the graphic chips at PCI Express port also. You can see in most of the motherboard have a graphics options. Some motherboard have a graphics option, some motherboard don't have a graphics. So there is a dedicated graphics you can connect here, and already there is a graphics inside the PCH also. This is a PCH also. Now this processor have a 2 port. One is called the DMI, another is called FDI. DMI for the other traffics, to control the other traffics like a data, and the FDI only for the display traffic, the separate port. Okay. So in this PCH, the PCH require this level of power. It's require 1.8, 1.5, 1.05 and 3.3. And RTC also. This RTC also is require a CMOS battery. And this clocks is gone into the PCH. In the Core Studio, there is a separate clock chip that we seen. But in this system, the clock chip incorporated into the PCH. So there is no separate clock chip. So these are the 2 ports. Now, so this architectures become like this. In Core Studio, we seen the architectures was different. There was a MCH, ICH and clock. Here is a no need of ICH, MCH and clock. There is only one chips who manage everything, that is called the PCH, which inbuilt ICH, MCH and clock. Now this one is a processor which connected directly to the RAM. These are the supply required to run this processor. This is a first generation processor, 988A socket, and This one is a PCH, require all these supplies. Here are the two crystal, one 25 megahertz for the clock,
Memory controller have
another is a RTC. Okay, now this is called the LPC bus, it's called the low pin count bus, which is connected to the SIO. And here you can see there are two bias. One is this bias, another is this bias. This bias is called the EC bias, embedded controller bias, and this work on a always voltage. And this PCH bias will work on suspended voltage. Always voltage means the voltage which turn on as soon as we connect the adapter or the battery is present. And the suspend voltage means those voltage which when we press a power button, that's time this comes on. That is called the suspend voltage. So this is a difference between the always and suspend. So this section, these two components are responsible for turn on the power, and this PCH bias is responsible for the display. Okay, so these are different. Now this PCH controller is there same as like ICH, only 2-3 components are inbuilt, like the graphics and the clock. And in the graphics there one section is that is the HDMI.
Graphics is in the MCH or ICH.
Inside the PCH. The graphics section inside the PCH. It's actual the graphics section in the processor, but it's delivered all the signal via PCH. Okay. So in this way this system works.
PCH
Now how to find whether PCH is working or not? How to find? There are three sequences. Like there are so many problem can maybe occur if the PCH is faulty. First, if the laptop is dead, and it's not powering on, so you have to check this signal. Whether he's getting the RSM RST, is getting the power button signal, but still it's not turn on. Then you have to check this two signal, that is called SLPS3 and SLPS4. If the PCH getting this two signal and he getting the power also, but is not sending out this two signal, that means PCH is bad.
straight away we
Yeah. Then if it is not saving the CMOS setup, you have to check this battery, you have to check this crystal, and then RTC reset. But still the CMOS setup is not saving, that means the PCH is bad. If you are not getting the clock, now these here this signal for the dead, here this signal for the CMOS not setting, and now we'll see if the laptop is power on but it's not giving the display. Laptop is on but it's not giving the display. So first of all you have to check the clock. The clock is inside in the PCH. So there is a 25 megahertz crystal connected to the PCH. You can connect the oscilloscope on these two legs. You will find 25 megahertz frequency. If this 25 megahertz frequency, that means the clock section is working.
the crystal frequency to show it, no?
Crystal frequency it will show.
But how to know clock is working when
You can assume that clock is working. If you are getting the crystal, you can assume. Then if you want to check the detail, then you can check this 33 megahertz clock.
no, generally
This 33 megahertz clock is you will find on the SIO, because this signal going on the SIO. You can't check each and every clock of the pieces because this chip is a BGA chips. You can't check, but you can check this clock. This clock is going to SIO. It's called the LPC clock. That is a 33 megahertz. You can check on the oscilloscope 33 megahertz there. That we seen on yesterday, I think. So this 33 megahertz is coming. That means sure that PCH clock is working. Right? So in this way. Then now if your laptop is power on but it's not display, the important signal you have to check is PLT reset. This is a platform reset. The platform reset means you reset the entire motherboard. Now how the reset signal generate? When the PCH received these two signal, that is called a power good and system power good. When this PCH received this two signal, power good and system power good, that this both signal coming from either from the SIO or from the pulse width modulator. It's depend model to model, but most probably from the SIO. If these two signals are coming, that then PCH have to send out this signal PLT reset. And if these signals are going into the PCH but this signal is not coming out, that means the PCH is bad. Got?
PLT reset signal कैसा होगा?
PLT reset, this signal you can check either on the SIO or you can check on a Wi-Fi card pin number 22. Wi-Fi card slot is there, no? On that pin number 22, you have to get a 3 volt there. Pin number 22.
SIO.
Or you can check on the SIO. It's a pin name is LPT RST.
It will be in voltage or?
It is will be voltage. Of course, it will be on voltage 3 volt. Now the next signal. If you got the PLT reset, okay. If you got the PLT reset, but
Power is okay.
all power is okay. Now, but still display is not coming. Then you can check this bias pin. You can check on pin number 1 if this bias is there. This is called a PCH bias. It's a PCH bias. You can check on pin number 1. This is a pin number 1. There is a dot is there. That is pin number 1. Connect the oscilloscope over there at pin number 1 or logic analyzer at pin number 1 and turn on the laptop. As soon as you turn on the laptop, you will find some waves. You will find some oscillation on pin number 1. Something, yeah. And that's are coming. That means PCH is responding. PCH is trying to access the bias. Then you can connect oscilloscope on pin number 2. That is a read pin. And when you turn on the laptop, just turn off and turn on again with connecting the oscilloscope at pin number 2. At that time, you will see some oscillation again. And if these oscillations are coming out, that means your bias is sending all the information to PCH. And if there is a flat, nothing coming out, that means your bias is bad.
So we reprogram that bias.
We have to reflash and see.
If the second pin, it will come.
Second pin is a pin number 2, that is a read pin. Pin number 1 is a chip select.
Yeah. If some oscillation is there.
Oscillation comes means bias is sending information to the PCH. What information is sending we can't say because it may be bias corrupt. But it's something sending. Okay. So in that way you can check. If all these 2 pins are okay, then you can check the next signal, that is called SM bus. You can check this 2 signal SM bus, system management bus, which is connected to the RAM slot. It read the SPD bias there. There is one small chip on the RAM.
That also through oscilloscope only.
That is also oscilloscope.
How much frequency?
It will not show frequency. It will show some oscillation, some lines, some frequency. What it is that we can't say, but it will come only on initial stage. Once you on, it will show some spike. And if that spikes are coming, that means PCH is okay and trying to communicate with the RAM. And still display is not okay. You can check the next signal, that is called a frame signal on the SIO. This all frame signal on the SIO. There also you will find some on and off signal with the help of oscilloscope. You can check with the help of oscilloscope. So in this way we seen how the PCH works.